Let's do a quick review of how exponential growth works. And to do that, we're going to look at a case study. And in this case, we're going to look at a species of malarial parasites. These are the parasites that cause the malaria. A host is infected when a mosquito that carries the parasite bites the host. This particular species is in mice, and what makes it different than the ones that infect human is that they replicate synchronously. They follow the circadian rhythm of the host as the metabolism reaches a certain point, and that happens every 24 hours. The parasite replicate. And so initially they infect a red blood cell, and every 24 hours they reach 8 inside of the blood cell, and then the blood cell bursts, and the newly released parasite infect more blood cells, and after every 24 hours each of those blood cells again burst and replicate into 8 more. So generally, if I look at that as a mathematical model, if we let P of n be the number of parasites after n days, initially at time 0, let's suppose we only had 1 parasite. What would happen is after day 1, we would have 8. And if we go back after day 2, each of those 8 would have replicated, and we would have 8 times the 8 we used to have, and that's 64. After day 3, those 64 each will replicate into 8 more. We have 8 times 64, which is 512. So we can write this equation as a recursive formula. So the number we have based on the number on we had the day before, and that's what the equation would look like. So P of n is 8 times P of n minus 1. So n minus 1 representing the day before. Now we can also look at this and try to write this equation explicitly. So if I go back and think about this in a different way, so if I say on day 0 I had 1 parasite, on day 1 that one would replicate to be 1 times 8, which is 8. And the second day, then I would have 8 parasites for each of the ones I had on day 1, 8 times 8. If I write that as an 8 squared, and if I continue this on the third day, I would have 8 times 8 squared, which would give me an 8 cubed. So I can write this as an exponential function and write it as P of n is 8 to the nth power. So on the third day, we have 8 cubed. On the second day, I'll have 8 to the second. On the fourth day, I would have 8 to the fourth. Right? So it's a basic exponential function. Generally, exponential functions look like this. So f of x, if I have a continuous function, so ours was discrete. It jumped from day to day to day because my parasites replicated synchronously. But generally, if it's a continuous function and write as f of x, we would have a times b of x. In our case, a was 1, so that's the initial number, and b represents the growth factor. In our case, b was 8. And notice b has to be positive, otherwise this function will not make sense. It will become undefined for certain values of x. Okay, so if I now look back and think about this, just looking at a representing the initial numbers. So if x is 0, I would have a times b to the 0. B to the 0 is 1. A times 1 would give me a, right? And if I compare what I have on day 1 with day 2, you'll notice it keeps growing by a factor of b. So b would be the growth factor. If we look at what this looks like graphically, here is a graph of a function 1 times 2 to the x. So notice at when the value of x is 0, my function is passing through 1, which is our initial value, and it grows by a factor of 2. So for every x value, it doubles. right? So at 1, it goes to 2. If I go to 2, it's at 4. At 3, it will be at 8. And as a changes, so if I make a bigger, so if a is 2, now my function passes through 2 on the y-axis, the y-intercept of 2, and that would be the initial amount. And as b changes, it grows faster and faster as b gets bigger and it becomes steeper. And if I go and then try a b that is smaller than 1, that means my growth factor is less than 1, and that causes my function to decrease rather than increase. So if my growth factor is 0.5, for example, it means my exponential function gets to be half as big for each x value. So just a quick review of how exponential functions work. We're going to be using them quite often in this class.